Hello, welcome to my system database presentation.
Hello, my name is Sky, and this is my proposed electronic system to monitor medications and lab tests for my master's program on informatics. The class is 521, Data, Information, and Knowledge with Professor Daria. Increased use of electronics in healthcare environment has opened the door to all types of helpful electronic systems. An electronic system that helps to monitor medications and the appropriate tests would prove to be valuable in ensuring all appropriate lab tests are done with certain medications that need them for dose reduction. This system will be used to provide reports that will assist users in the authorized use to adjust medications, schedule labs, give medications, and bill insurances. My system should display needed labs for each patient in relation to meds taken, alert staff if last lab values were abnormal, alert staff on the need to alt med, adjust med, or notify the doctor. It will display all users and their current licenses and display the need for additional documentation. The system should do this in an accurate, fast, and easy way to use the system. Needs such as scalability, which is the ability to grow and manage businesses, increases demands, performance such as response time, reliability by performing consistently well, availability, which is the quality of being available to be used without loss of performance, recoverability by being able to recover all data, maintainability, the ease of maintaining the system in order to correct errors and updates, securing requirements to maintain patient information, safe data integrity by keeping data accurate and valid, usability in using the system with easy and without user fatigue, and interoperability of the system, as in being able to exchange information between computers and other devices, regardless of who manufactured them. My system will be a relational model design with emphasis on minimum data duplication to facilitate storing all kinds of data in a cost-effective manner. It will be user-friendly so that anyone with minimal computer skills can use it, data maintenance to help performance, free up the disk space, check for data errors, check for hardware faults, and update routinely. It should have a high level of security where patient information is safe and protected from HIPAA violations. It should have permanent storage of data where the data will not be lost in case of power failure when the device is unpowered. There are 10 questions to ask end users to make my system user-friendly and beneficial not only to the organization but to the end users. What do you expect this software to accomplish? What are your needs and requirements? Do you require the system to have interoperability? How important is usability versus speed? How important is consistency? What is the current operations and processes? What is missing from the current system? What are your security concerns about the system? What is the end user's predicted level of exposure to technology? What buttons or actions can be added to make documentation efficient and accurate? This system will have several tangible deliverables, such as verification of licenses report, service report to verify services rendered, accurate insurance billing, improved patient care with all necessary services provided, and safer patient care where patients will benefit from the right medication dosage and adjustments. There are 5 use cases, but 3 are of significant importance. Use case user designator that will authorize certain users to access the system, medications, and labs. The entity relationship diagram describes the relationship between entities and attributes. Entity user designator will have the attribute of patient and clinical staff. Patient will have the further attribute of first name, last name, room number, MMR number, and date of birth. Clinical staff will have the further attribute of first name, last name, user ID, and credentials. Credentials will be further subdivided into MD, NP, PA, RN, LPN, or MedTech. My entity user designation will have a relationship of taking medications, giving medications, or monitoring medications according to the user designation. It can also have a cardinality of entity user designator one-to-many entity medications. Entity medication will have attributes of description, alternate med, diseases, and value. Value will be subdivided into elements of critical high, normal, low, and critical low. Medication will have a relationship of needs to the entity of lab work with a cardinality of many to many. The entity lab work will have attributes of lab name, schedule, and MD order. MD order entity will have a further element of yes or no. The entity of lab work will have a relationship of requires with the entity of follow-up. Follow-up will have the attributes of evaluation and met changed, and a cardinality of one-to-many. The entity follow-up will have a relationship with the entity documentation. It will be a cardinality of one-to-one with the entity documentation having attributes of lab completed, meds changed, and followed up. According to current research, most systems use a web development framework with tools to automatically generate the source code for CRUD operations. Using stored procedures, reserve and reuse for all summons of the stored procedures, CRUD are the four basic functions of constant storage applied in a relational database, storage applied in relational database applications. It has the ability to create or add new entries, such as a new patient or a new clinical staff or a new medication. It can retrieve, read, view, or search available entries, such as reports needed. It can also update, revise, display, search, or edit existing entries, such as lab values or clinical staff licenses. It can also deactivate, delete, or eliminate available data, such as patients who died or were discharged and staff that quit or were terminated. There are several reports a user can run based on the application of this database. For example, from the entity user designation, a report can be run on all the patients in the system. On the entity follow-up, a report can be run on how many medications had to be adjusted for a certain time period. In the entity of lab work, a report can be run of all the lab work completed weekly. In the medications entity, a report of all medications given for a certain time period can be run. In the follow-up entity, a report of all follow-up with the dosage adjustments can be run. And in the documentation entity, a list of all documented critical labs can be run for educational purposes. To minimize loss of integrity, loss of availability, and loss of confidentiality, 3 security measures will be built into my system. Function access control will ensure restricted access by unauthorized users with the use of user-specific accounts and passwords. Inference control function will monitor unauthorized use access to certain statistical information that can lead to certain conclusions by users. A coding algorithm regulates information by encrypting information that, unless the user has a key, cannot decipher. There is a need to monitor patients with blood work while using certain medications. My proposal system is about an application that would allow data elements to be caught inside the database and run through a rules engine that would communicate to the end user the appropriate lab tests needed according to the medication list. This proposed database would work as a clinical decision support system with a rules engine that prompts the end user at the right time. The benefit would be a smooth workflow where lab tests are done in a timely manner consistent with pharmacy and state guidelines. This simple system should integrate well with the current electronic health record and benefit the organization with less errors and liability and provide safe care to the patients.